Welcome to the Exponents UYAS video. This entirely optional video is here to help you prepare for your first UYAS quiz on exponents. And I guess we'll start with the multiplication property of exponents. Let's say, for example, I've got something like x to the 5th times x to the 6th. It's going to be equal to x to the 11th. What I did computationally there is I just added the exponents. Of course, that's not really what's going on. What's going on is I've got 5 factors of x here, 6 factors of x here. All told, I have 11 factors of x, which we express as x to the 11th. So taking a look at this example, I'm going to multiply these two expressions where I've got x's, y's, and regular numbers. And this is going to operate somewhat similar to when we combine like terms, except here we're going to be looking at multiplying terms with the same bases. So for example, I can do x to the 4th times x squared is x to the 6th. I can do y times y cubed. Remember, y is y to the 1st. It's going to give me y to the 4th. And then I can just multiply my numbers normally. So I get 6x to the 6th, y to the 4th. So I just looked at multiplying all the x's together first, then all my y's together first, then all my numbers together. And I probably could have made it a little bit easier starting with the numbers, but it doesn't really matter the order you approach it. So here's another example you can work out. I'm not going to go through an explanation of this, but if you want you can pause the video for a second and work this one out. And the answer we should be getting is 35 a to the 4th b to the 8th y to the 4th. And I should clarify that's a y squared there. And notice that in my answer I chose to go A, B, Y, do it in alphabetical order, but it doesn't matter the order. You have those different exponential expressions with the different variables. Another one of the important properties for us is this division property. So if we look at x to the 11th over x to the 6th, the result is x to the 5th, which we obviously get just by subtracting the exponents, but that's not really what's going on here. And if we remember back to the previous slide, this makes sense because we did say that x to the 5th times x to the 6th was x to the 11th. But let's take a quick look at what's actually going on here. I'm saying that in my numerator I've got 11 x's, and now I'm wishing I'd chosen a smaller exponent. 4, 5, 6, 7, 8, 9, 10, 11. In my denominator I've got 6 x's, 1, 2, 3, 4, 5, 6. And what's happening is, well, 6 of these factors of x are canceling out, and what do I have left? I've got 5 factors of x. So that's why this type of thing works. And I could also have the inverse, where I could have x to the 6th over x to the 11th. That's going to be 1 over x to the 5th. Because again, I have 6 factors of x canceling out over here, leaving me 5 factors of x, but those 5 factors of x are going to stay in my denominator. So let's take a look at this example. 8x squared times y cubed, and that quantity divided by 6x to the 5th y. And what we're going to do is, just like last time we multiplied expressions with the same bases, here we're going to look at doing the division between these exponential expressions with the same bases. So I'll go ahead and put my fraction bar in and say, okay, I've got 2 factors of x in my numerator, 5 in my denominator. When that cancels out, I'll end up with 3 factors of x remaining in my denominator. I can similarly look at my y's. Y cubed over y is going to leave me a y squared in my numerator. And then as far as the numbers go, I'm just going to go back and I'm going to look to reduce this fraction. Both the numerator and denominator of 8/6 are divisible by 2, so I'm going to get 4/3. And that's going to be my answer right there. If you want, you can make it look nicer and say 4y squared over 3x cubed. And I'll go ahead and put a second example here for you. So here I have 27a to the 4th b squared, that quantity divided by 12b a to the 15th. And I'm not going to work this one out, but you can pause it here and work it out yourself. And my solution is going to be 9b divided by 4a to the 11th. The next thing we're going to look at is powers of exponential expressions. Let's say, for example, I had x to the 9th and that quantity gets squared. Well, what does this squaring mean? It just means multiply x to the 9th by itself. So we'd have x to the 9th times x to the 9th will give me x to the 18th. So when I have powers of powers, I actually get to multiply these two powers. Let's take a look at an example that's a little bit more complicated. So here we have the quantity 3x to the 4th, that quantity raised to the 3rd power. And when I've got a quantity raised to a power like this, I need to make sure that the exponent gets applied to each term in here. So first I'll look and I'll say, okay, 3 to the 3rd. 3 times 3 is 9, times 3 is 27. And then I'll say x to the 4th cubed. Well, 4 times 3 is 12, so that's x to the 12th. So again, just make sure that the exponent here gets applied to each term in parentheses. Then I say x to the 4th cubed is x to the 4th times x to the 4th times x to the 4th gives me 12 factors of x. We can also do a similar thing when we've got a fractional quantity that we're raising to a power. We need to make sure that this power here, this second power, gets applied to everything in the quotient. So I'll look at this and I'll say, okay, 4 squared is 16, x squared squared is x to the 4th. Those are my two terms in the numerator. And then y to the 1st squared becomes y to the 2nd. And we'll do one more example that's a little bit more complicated. So maybe this example is more than a little bit more complicated. We've got a big messy fraction here that we want to raise to the 3rd power. That's 10a cubed y to the 4th z over 15a y squared z cubed, and that whole expression is getting raised to the 3rd power. The first thing we're going to do here is simplify that fraction. So we'll get that that's 2a squared y squared over 3z squared. And that whole expression is getting raised to the 3rd power. So 2 cubed is 8. Then we'll get a squared to the 3rd is a to the 6th, y to the 6th over 27z to the 6th. So there we have it with an example that's a little bit more complicated. And there's one final piece we're going to look at. If I look at these various powers of 3, to get from 3 to the 1st to 3 to the 2nd, I multiply by 3. To get from 3 to the 2nd to 3 to the 3rd, I multiply by 3 again. So, if instead I wanted to go the other direction, so to go from here to here, I'd be dividing by 3. And to go from here to here, I'd be dividing by 3. So every time I decrease a power by 1, I'm dividing by 3. So what happens if I look at 3 to the 0? Well, I would want to be dividing by 3 again to get down here. 3 divided by 3 is 1. And this is our last fact. Anything to the 0 power is equal to 1, except 0 to the 0. And we are not going to worry about that. So for our purposes, anything raised to the 0 power is 1. Just make sure that that base isn't 0. So this should be everything you need to get ready for your UYAS quiz on Tuesday. We also will have a practice worksheet and solution key on the website along with this video. So after you watch this video, you can go get some practice in before class on Tuesday. I'll see you then. Bye-bye.